everyone, I am your student teacher for today and I am Maria Melanie Pipaha, a third-year college student from Mindanao State University.
So today, I'm going to discuss to you the mathematics problem involving geometry. Problem number 1. In the diagram below of circle O, chords AB and CD intersects at point E. If the measure of angle AEC is equal to 34 degrees and the measure of arc AC is equal to 50 degrees, what is the measure of arc DB? So here are the choices. A. 16 degrees, B. 18 degrees, C. 68 degrees, and D. 118 degrees. In this problem, we can apply the Theorem 2 of angles formed by tangents and secants. So, secants are the lines that contains a chord. Since AB and CD are chords, so they are also considered as secants. So, according to the theorem, if two secants intersect at the interior of the circle, the measure of the angle is equal to 1/2 of the sum of the intersected arc. Our formula for this problem, based on the theorem, would be measure of angle AEC is equal to 1/2 measure of arc AC plus measure of arc DB. But the question is, what is the measure of arc DB? So, deriving this formula, we arrive for this new formula. So, measure of arc DB is equal to twice the difference between measure of angle AEC and half the measure of arc AC. Substituting the values given, so we have 2 multiplied by measure of arc angle AEC is 34 degrees less half of the measure of arc AC, which is 50 degrees. To simplify, 34 degrees less 1/2 of 50 is 25. 2. So 34 minus 25 is 9. So multiply these two. So we arrive with an answer 18 degrees. Therefore, the measure of arc DB is 18 degrees. Therefore, our answer for problem number 1 is letter B. Number 2 problem. Circle O with angle AOC and angle ABC is shown in the diagram below. What is the ratio of measure of angle AOC to measure of angle ABC? So here are the choices. A. 1:1, B. 2:1, C. 3:1, D. 1:2. So let's have a recall. What do you think does this angle is called? Yes, it is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. How about the angle who's at the center of the circle? What do you call that? Yes, it is a central angle. Therefore, angle AOC is a central angle. So, in the problem, we are asked what is the ratio of angle AOC to angle ABC. Since we identify that ABC is an inscribed angle, we know that the measure of an inscribed angle is equal to 1/2 of the central angle intercepting the same arc. Therefore, the formula is A alpha is equal to 1/2 theta, wherein A refers to the inscribed angle and theta is the central angle. If we wanted to find the measure of the central angle, we could just derive the formula into theta is equal to twice the alpha. Here, thus, it means that the central angle is twice the measure of inscribed angle, giving us a ratio of 2:1. Hence, the ratio of angle AOC to angle ABC is 2:1. Therefore, our answer for this problem number 2 is letter B. Number 3 problem. In the diagram below, ray RCBT and triangle ABC are shown with an angle A measures 60 degrees and the measure of angle ABT is 125 degrees. What is the measure of angle ACR? So here are the choices. A. 125 degrees, B. 115 degrees, C. 65 degrees, D. 55 degrees. If we observe the diagram, angle ABT and angle ABC are adjacent angles. Adjacent angles are two angles having a common vertex and a common side. Since angle ABT and angle ABC are adjacent angles, we can also say that angle ACB and angle ACR are adjacent angles. And they also form a linear pair. A linear pair are two angles formed by two adjacent angles, which are formed by the union of a line and a ray. Since linear pair are supplementary, we can find the measures of angle ABC. Since angle ABT is given, we can use this to find the measure of angle ABC. So our formula for this is measure of angle ABT plus measure of angle ABC is equal to 180 degrees. Adding the inverse of angle ABT to the both sides, we have measure of angle ABC is equal to 180 degrees less measure of angle ABT. So substituting the value, we have measure of angle ABC is equal to 180 degrees less 125 degrees. Therefore, measure of angle ABC is equal to 55 degrees. Now we have two angles given for triangle ABC. Since the sum of the angles in a triangle is 180 degrees, we can use this to find the measure of angle ACB. So we have measure of angle CAB plus measure of angle ABC plus measure of angle ACB is equal to 180 degrees. Substituting the values, so we have 60 degrees plus 55 degrees plus the measure of angle ACB is equal to 180 degrees. Adding these two, it is 115 degrees plus measure of angle ACB is equal to 180 degrees. Adding the inverse of 115 to the both sides in order to find the measure of angle ACB, we have measure of angle ACB is equal to 180 degrees less 115 degrees. So therefore, the measure of angle ACB is equal to 65 degrees. Since angle ACD and angle ACR are linear pairs and linear pairs are supplementary, we can now find the measure of angle ACR. We have measure of angle ACR plus measure of angle ACB is equal to 180 degrees. Adding the inverse of measure of angle ACB to the both sides so that we can have the measure of angle ACR. So our new formula is measure of angle ACR is equal to 180 degrees less measure of angle ACB. Substituting the value of measure of angle ACB, we have 180 degrees less 65 degrees. Therefore, the measure of angle ACR is equal to 115 degrees. Therefore, our answer for the problem number 3 is letter B. Problem number 4. In the diagram below, diameter AB bisect chord CD at point E in circle F. If AE is equal to 2 and FB is equal to 17, then the length of CE is A 7, B 8, C 15, D 16. If we observe the diagram, we can notice that line segment FB is a radius, hence line segment CF is also a radius. Since line segment AB bisect line segment CD, it forms a perpendicular line, and if we observe, this figure forms a right triangle. If line segment FB is a radius and line segment CF is also a radius, therefore, the measure of this line segment CF is also 17. So to find the measure of this side, we can also say that line segment FA is also a radius and measures 17. Since AE is 2, so 17 minus 2 is equal to 15. Therefore, line segment EF measures 15. We are asked to find what is the length of CE. So taking out this figure or drawing this in our scratch paper, we have this. Since it is a right triangle, we can use the Pythagorean theorem in order to find the length of CE. And the formula of Pythagorean theorem is C squared is equal to A squared plus B squared. And deriving this formula, we have A is equal to square root of C squared minus B squared. Substituting the value given, we have square root of 17 squared plus 15 squared is equal to 289 less 225. 289 less 225 is 64, and the square root of 64 is 8. Therefore, the measure or the length of CE is 8. So, our answer for problem number 4 is letter B. Problem number 5. Triangle ABC is a right triangle with AB is equal to 24 cm and BZ is equal to 10 cm. The length of hypotenuse is A 21 cm, B 26 cm, C 30 cm, D 52 cm. This problem doesn't have a diagram, and since it mentioned that triangle ABC is a right triangle, we can redraw this in our scratch paper. So here is our diagram, and we have the given AB is equal to 24 cm, BC is equal to 10 cm, and we are asked to find for the measure of hypotenuse. We should remember that the right triangle has three sides, the long side, the short side, and the longest side. And longest side also refers to hypotenuse. And if we compare the length of AB to the BC in terms of their measurement, we can see that AB is longer than BC, so therefore AB is the long side, while BC is the short side. Since it is a right triangle, we will utilize Pythagorean theorem in order to find the measurement of hypotenuse or the line segment AC. And the formula of Pythagorean theorem is c squared is equal to a squared plus b squared. And to simplify this, since we are asked to find for one side of the hypotenuse, which is c, we have square root of a squared plus b squared. Based on the given, we let a as 24 centimeter while b is 10 centimeter. So we will now substitute this value to our formula. Therefore, c is equal to square root of a, which is 24 centimeter squared, plus b, which is 10 centimeter squared, is equal to 576 centimeters squared plus 100 centimeters squared. Adding these two, we have 676 centimeters squared. And the square root of 676 is equal to 26 centimeters. Hence, the length of hypotenuse is 26 centimeters. Therefore, our answer for problem number 5 is letter B. Number 6 problem. Gina made a box in the form of a cube with edges 50 centimeters long to use as a display table. To cover it with wallpaper, she will need A. 3 meters squared, B. 2.5 meters squared, C. 0.25 meters squared, or D. 1.25 meters squared. This problem doesn't have a diagram, so we will draw the figure in our scratch paper. So here is what we have drawn based on the given problem. We will just take one side of a cube and this is what it looks like. We know that the area of a square is equal to s squared, by which s refers to the measure of the side. And substituting it with the given, we have 50 centimeter squared. And 50 centimeter squared is equal to 2,500 centimeter squared. But we need to convert it into meter squared since the given choices are in meter squared. So, we know that 1 meter is equal to 100 centimeters. So to square the both sides, we have 1 meter squared is equal to 10,000 centimeters squared. So we can now convert this into meter squared. So we have 2,500 centimeters squared over 1 multiplied by 1 meter squared over 10,000 centimeters squared. Since we wanted to cancel out the centimeter squared unit in order to retain the meter squared unit, this is what it looks like. So cancel this unit, and 2,500 divided by 10,000 centimeter is equal to 0.25 meters squared. Hence, Gina will be needing 0.25 meters squared wallpaper in order to cover the box that she formed. Therefore, our answer for problem number 6 is letter C. That ends our video tutorial for this moment. I hope you learned something. Have a good day. God bless. Bye!